In this problem, we need to simplify the given expression. So let's begin by stating the De Moivre's theorem. So whenever we have cosine of theta plus iota times sine of theta whole raised to the power of n, then this becomes equivalent to cosine of n theta plus iota times sine of n theta. This can be also written in a compact form as cis of theta raised to the power of n equals to cis of n theta. So here cis will represent, the c represents the cosine, I is the iota, and s is the sine function. Right. So let's begin. So we'll first start with the numerator. So here in the numerator we have I raised to the power of 5 multiplied to sine to theta plus iota times cosine to theta. Now iota raised to the power of 5, so let's try to simplify this. Or iota raised to the power of 5 can be also represented as iota raised to the power of 4 multiplied to iota. Now here iota raised to the power of 4, this value is 1. So well stated, iota raised to the power of 4, this is 1. So that means we have simply iota, or we can say that iota raised to the power of 4 is equivalent to iota. So this is iota. Now here we have within the parentheses, the real part is given by the sine function and the imaginary part is the cosine function. Whereas if we are to apply the De Moivre's theorem, the real part should be cosine and the imaginary part should be sine function. So that means we will need to simplify this. So let's do one thing. So we will multiply iota with the terms inside the parentheses. So we'll have iota times sine 2 theta plus iota squared cosine of 2 theta. Now we know that iota squared, that's by definition equals to -1. So that means we have negative cosine 2 theta. So we're writing the real part first. We have negative cosine of 2 theta plus iota times sine of 2 theta. Right. What we can do, we can take negative as the common factor. So we will now have negative multiplied to cosine of 2 theta minus iota times sine of 2 theta. Now we know that cosine is an even function. So if it is an even function, then we can say that cosine of negative theta is equals to cosine of theta. That's because our cosine is an even function, whereas our sine is an odd function. So a odd function would mean that whenever we're sine of negative theta, this will be equals to negative sine theta. Now we will use this particular fact to rewrite a given expression. So that means we will have negative multiplied to cosine of, so cosine of 2 theta can be represented as cosine of negative 2 theta. And we can absorb this negative sign inside the sine function and we can write it as positive iota times sine of negative 2 theta. Fine. So this means we can now apply our De Moivre's theorem. So this is actually equivalent to cis of negative 2 theta, or simply put, we have negative of cis of positive theta raised to the power of negative 2. We have applied the De Moivre's theorem. Now that means our expression in the numerator, this is also expressed as negative of cis of theta raised to the power of negative 2. So let's substitute this value. This will be equals to negative of cis of theta raised to the power of negative 2. Here we also have to take care of this negative sign in the denominator portion. So let's quickly tackle that as well, where we have cosine of theta minus iota times sine theta, which can be also expressed as cosine of negative theta plus iota times sine of negative theta, which means we now have cis of negative theta, and this becomes equals to cis of theta whole raised to the power of -1. Now we also have whole squared here. So if we square, then this will become squared. So this, and we'll have -2 divided by cis of theta raised to the power of -2. So here the numerator and the denominator gets completely factored out, and this is leaving us with a value of -1. Hence, the simplified value of this particular expression is -1.